In this unit, we are going to learn integration by parts in order to find antiderivatives of functions like, say, x times sine x, in which we have both the factors having antiderivatives, or in other words, we can find the antiderivatives of x as well as that of sine x, but we do not have any product rule for integrals that I know. Okay, so we are going to look at, or rather we are going to develop a technique by which we can look at integration of a part of this function, or say a factor of this function, and use that to find the antiderivative of this entire function. Okay, so let's see how we obtain that. So let's say we have a product of two functions, u and v, and the product be say w. Okay, so if we take the differentials of both the sides and we have a product rule for differentials, what shall we get? We shall get dw equals u times dv plus v times du. Okay, now once we have this, we can take the integrals now, all right, of both the sides, and integral of dw would be what? Simply w. Okay, and here we have the right hand side. So now you can see this here, that here we are looking at the integral of a part. Here we are taking dv. Of course, integral of dv is v, but we can take some other function and proceed with that in the direction that we are going to cover soon. Okay, so now I put the value of w back as uv, so we have uv equals that, and once we isolate this integral u dv, here we have what people call the rule or the equation for integration by parts. Okay, so let me show you an example in which we will work it out. So here is our rule for integration by parts. Okay, and let's take up the question that we took in the beginning, that is integration of x times sine x. Okay, so in here we can see that, well, I can have antiderivative of x and as well as that of sine x. Okay, but if I integrate x, I'll get x squared over 2, which will go on growing. So it'll be more appropriate to take u as x and integrate who? Sine x. This will work many times, but don't take that as a permanent rule forever. Okay, so I took u as x and dv as sine x dx, and then we're going to use du, the differential, that will be simply dx, and who dv will be? The antiderivative of sine x, which is what? Negative cosine x. So we have u as x and v as negative cosine x. Now let's go ahead and use this rule to obtain the antiderivative of x sine x. Okay, so we have this again, integral u dv equals that. Okay, and then we have u as x, which gave us du as dx, and v as negative cosine x. So when we have our integral here, u is x, v is negative cosine x, and then I substituted v and du here. Okay, and then when we do that, what will happen? We get integral of x sine x as what? Negative x cosine x plus integral of cosine x. Okay, now these two negative signs then become positive here. Okay, and antiderivative of cosine x is sine x. So we got negative x cosine x plus sine x as an antiderivative of this product x sine x. Now we can use this technique of integration by parts to find antiderivative of the functions which were not in the commonly used glossary of table of integrals, such as, first again visit this rule that we have, and say we have to integrate natural log of x. So in this case, what we may do is we may take u as natural log of x and dv as dx, because if dv is dx, v will be x, and I know that the derivative of natural log of x is how much? 1 over x. So since we know that, then we have du as 1 over x dx, and here v will become x. And then when we proceed further, okay, what we have, just put all these values in here. I have natural log of x for u, x for v, and I have put parentheses here just for sake of clarity. Okay, and v is x, and then du is 1 over x, and these x's will cancel, okay, when we come down to the final evaluation, as you will see in a second. So here I just wrote that up here again for you. Okay, so x is cancelled. So what we got, I rearranged it just to make it look clearer. And here x is cancelled, and I have simply integral dx, and which is going to become what? Simply x. So the antiderivative of natural log of x is what? X natural log of x minus x. Okay, that's an antiderivative of natural log of x. Now let's take a slightly different flavor here. Again, I rewrote the rule for integration by parts for you here, and say we are integrating x times natural log of x. Now we know that we just did it. We have antiderivative of x as x squared over 2, and that of natural log of x as x natural log of x minus x. But in this case, notice this, that taking this as u is going to give us a little more complicated quantity. Okay, so it will be a better idea to use this part as u, and then x dx as dv as see, I just rewrote the same thing, and you know these are equal because of commutativity of multiplication. Okay, so once you do that, you can take u as natural log of x, which will give you du as 1 over x dx and dv as x dx, and then integration produces v equals x squared over 2. Okay, and so that's what we have. And then going further, when we apply this on this integral and use the integration by part techniques, what we have for u, we have natural log of x, this is my v, and then this is my v, and this is the du. Okay, so there we go. This x cancels this x squared, sorry, this is square, or this x reduces the x squared to x. Okay, so what we got is we have x squared over 2 natural log of x. I just wrote them in reverse order. Okay, and here antiderivative of x will be x squared over 2, and 2 times 2 will be what for us? That will simply be 4, and that's the final, and that's a final answer for that. Okay, now I'm considering this one, and this one I'm going to go a little faster over, like I did not write the rule for integration by parts, assuming that now we have gotten used to it. So we are taking u as x squared, dv as sine x dx. So once we do that, what will happen? The integral of sine x is negative cosine x, okay, and u is x squared. Then we have v du. So what we got? Negative cosine x here is v, and then here we got du as 2x dx. Okay, so then the next is we have this integral to deal with, and we will go over that in the same fashion. Okay, so first I think it'll be a good idea to rearrange it, which I did. I just factored, you know, -2 out. It's constant, so it just comes out or walks out of the integration sign easily, and I have x cosine x. Then I'll again repeat the process with x equals u and cosine x dx equals dv. So what that gives me, x, antiderivative of cosine x is sine x, then I have a negative sign, then I got negative cosine x dx here, and then I can combine all the negative signs to for them to come out, and the value will finally be what? That we have, and I think I have messed this one up. So I had made a strange mistake. I have the final answer correct, but I had done what? Made a mistake in typing or whatever. As long as we are fixing it, we should be okay. All right, so this should be what? This is right here, sine x, and then we got lots of things here, so give me a second. Integral of sine x will be negative cosine x, so we get negative, 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 and all that becomes what then? Positive. I have this outside. Okay, so let me go to the next one, and here we have plus 2x sine x plus cosine x, as we will desire it to be here. Okay, so here you can see that there were just too many calculations, and many of us might have been like becoming impatient with that. So if you followed, or if you cared to listen to me through the whole thing, let's see how we can abbreviate it in a shorter procedure as we had in algebra, along the lines of synthetic division. See what I'm doing here in this column? I'm doing this. See, we had chosen this for differentiation, so I'm going on differentiating this to x squared, then 2x, then 2, and then the derivative of 2 is 0, and I'm integrating all of these because I had to integrate them. So sine x became negative cosine x, okay, and then negative cosine x became negative sine x. So I had the mistake carried on here, haven't I? Sorry about that. Okay, so let me fix it. Okay, I should have fixed it before, or I don't even know whether I'm doing a wise thing by not going back and correcting and doing it right on this part, but it's okay. Let's see. So this is negative sine x, and then from negative sine x, what we got? We got negative cosine x. Okay, so let's see how we can combine these, so that just by looking at this column and combining this column in a proper way will lead us to the same result. So give me a moment. So we will combine the columns diagonally, as we said, in an appropriate way. So notice this x squared is multiplied with the integral here. An integral is sitting here, so we will multiply it diagonally, okay? And then 2x will be multiplied with the integral of that, but I have a negative sign here, when that comes in from the rule for integration by parts, okay? So what I will have to do, that whatever product comes out, I have to change it to what? I have to change it to negative of that product. Just a second, okay? All right. So we will take whatever product we have here, we'll take it as negative of that product, okay? And then in the next one, now in the next one, we are not going to change sign, because we will have two negative signs being produced because of the repetition of the part of the formula of integration by parts. So we'll leave that as positive, and then what happens next? Once we do this, multiply these two, what do we get? We get this term, multiply this with this and take negative of that, we get this term, and then multiply these together, we get this term, and after this everything is out of our way. So we add a constant here, and then we get the same answer. Okay, so this is a special formulation or a shortcut when we have some special situations. So as our final illustration, let's take a quick example of that. Okay, and then hopefully you will be able to do all the exercises. So this shortcut that I'm going to show you is called tabular integration. Okay, and that works when we have functions such as these, for example, in which we have this factor as x to the n, where n is a positive integer, and the other factor is of one of these three forms. Okay, so you can apply this, and let me take an extension again. In the same way, say we are integrating x to the power 4 times sine x, then I'll differentiate x to the 4 and go on integrating the second one. So I'll differentiate x to the 4 and going to integrate sine of x to get what? 4x cubed, and antiderivative of sine x is negative cosine x. Okay, and then what I get, I differentiated again, got 12x squared, and this became the antiderivative of cosine x is sine x. So I simply got what? Negative sine x. And here I went ahead and completed the whole list until I got down to a 0 here, which will not give us anything further. Okay, now we are going to do what? We are going to combine them diagonally. Okay, so here we are, we combine these, then we switch these, we take negative of whatever product we get, we keep this the same, then we'll keep on alternating like that. Okay, and then we will arrive at our final result in the following fashion. That is, notice that this will give us what? This will give us this term. Then when we take negative, negative is positive. Then when we multiply those, we get 4x cubed sine x. And here what we get when we multiply these, 12x squared sine x. And these two multiplied together give us negative 24x sine x. And here we get negative 24 cosine x. And in this fashion, right here is our answer for this integral. Okay, so work on the assigned exercises and let me know if you have any questions. All right.